Okay, so this is in response to homework 5.4-5, number 3. And they want us to find the area under the curve. So basically what we want to do is set up an integral, like we have here, and we see that it's from 1 to 16, so those are going to be our bounds, 1 to 16. And they give us this as the equation of the line here. So we just put that in our interval and add dx. Now, what we want to then do is use u-substitution, right? So we decide what to make u, and I'm going to make it radical x, which can be rewritten as the same thing, x to the 1/2. So then when we go and we want to find du, we want to take the derivative of u. So we're going to take the derivative of this. So we move the 1/2 out in front, the x stays there, and then we decrease our exponent by 1. So if we decrease 1/2 by 1, we get negative 1/2. Oops, that's supposed to be a half. There we go. And we can rewrite that as 1/2 x to the negative 1/2, and we rewrite that with positive exponents again, and it's 1/2 radical x, and don't forget your dx. There should be a dx for all of these. Sorry about that. Okay, so now, right now, we have du equals 1/2 radical x dx, right? And when we plug in with our u substitution, we also want to plug in for du. So what I like to do with this point here is rearrange this to get it into dx equals. So we want to get it into dx equals something. And whatever this something is, we go ahead and put that in instead of dx, and everything will be in terms of u. So what we can do here is we want to get dx by itself. We want to somehow cancel this. So we can multiply both sides by 2 radical x. And boom, boom, they cancel. So we get dx is equal to 2 radical x du. So now what we're going to do is kind of use our u substitution and plug in. And we can always move this 4 out in front, right, because that's a constant. So our integral is now 1/, instead of radical x, I'm going to say u, and instead of dx, I'm going to put this whole thing in for dx. So we have 2 radical x du. And this is how the du gets in there, because we made dx equal to this, and if we are integrating in terms of u, it has to be du. And this 2 here can also be brought out in front as a constant, right? So that's going to be 4 times 2, so that's going to give us an 8 out in front. We still have the 1/u, and now if we look, radical x is u up here, right? So we can rewrite that as times u, and the du is still there. And now, if we have u/u, that actually simplifies to 1. So we get 8 integral of 1 du, or basically just the integral of du, which gives us, if we integrate du, that just gets us back u. And one thing I do want to point out, I know the question was mostly on the u and the dx and the du, so I hope that was made clear, but I also want to point out, once you do u substitution here, see how originally our bounds were 1 and 16? You have to make sure that you don't put the bounds 1 and 16 in here, because these bounds are in terms of x. These are technically x equals 1 and x equals 16. So you can't put 1 and 16 here because they're not in terms of u. So you just want to be careful of that. So what I do is just get rid of the bounds until the very end, and then I go ahead and put in my original in for u, so it was radical x, and now I add back in my original bounds, and then you would be able to solve from there, right? You plug 16 in for x. Well, I can just do that. So we plug in our upper bound, minus, plug in our lower bound, and radical 16 simplifies to 4. So we have 8 times 4, which is 32, minus 8 times radical 1, which is 1, and that gets us 24 as our answer. But the important thing you want to do is when you find your u, when you then solve for du, get it in terms of dx. Get it dx equals, and then you just put this whole thing in for dx here, and it makes it a lot easier. You'll end up with more cancellations. And I hope that helps. All right, good luck.